In this video, we're going to prove the famous theorem called Cauchy-Schwarz Inequality. Basically, it says that if you have two vectors u and v in Rn, then the dot product, which is a scalar, so if you take the absolute value of the dot product, it will always be less than or equal to the length of u times the length of v. Now, let us consider the following. Consider the length of u plus t times v, where t is a scalar, actually the square. Well, this is going to be at least 0. The length of a vector, when you add those two vectors, you get a vector, and the length of a vector is either 0 or positive. The length can't be negative. But this here is the same as u plus tv dotted with itself. This is greater than or equal to 0. Now let's compute this dot product. You have u times u dot u. Well, that's the length of u. And you have u dot plus u dot tv plus tv dotted with u plus tv dotted with tv. And we know this is at least 0. And actually, that's the length of u squared, excuse me. So, we have the length of u squared plus, now this here is the same as the scalar times u dot v, plus this is the same as the scalar times v dot u, which is the same as u dot v, plus this scalar is t squared times v dot v, and this is known to be positive. We have the length of u squared plus 2 times t times u dot v plus t squared v dot v. Why, that's the length of v squared. And this is known to be greater than or equal to 0. Rearranging this, writing this first, this is the same as, I want to write this as a polynomial in t, a quadratic in t. In fact, it's the length of v squared times t squared plus 2 times u dot v times t plus the length of u squared, greater than or equal to 0. Now, if I call this a and this b and that c, you have at squared plus 2t plus c, something went wrong, plus bt, a, b, c, plus bt is greater than 0. Well, for a polynomial to be greater than 0, that means it either goes like this or that, and it has no roots. That would mean that the discriminant would have to be less than 0. Okay? Now, a polynomial, if it does equal 0, or greater than 0, it goes like this, or it goes like that. In either case, the discriminant must equal 0. So this discriminant is less than or equal to 0. But let's write it in the old language. B is 2 times u dot v. So that's b squared. Oh, this is the same as b squared being less than 4ac. I prefer to use that. So I wrote down b squared, and that's going to be less than 4 times a. A is the length of v squared, times c, which is the length of u squared. Well, 2 squared is, or 2, I meant to say 4, times u dot v squared, and this is less than 4 times the length of v times the length of u. Knock off the 4's, so you have u dot v squared is less than, these are real numbers, I can commute them, the length of u squared times the length of v squared. I take the square root of the left side, I get u times v absolute value. Now both of these are positive, so the square root of, u and v, the length of u and the length of v is positive. So I get the length of u times the length of v. I don't need the absolute values. And we concluded that this is true given any two vectors u and v and scalar t. You can let the scalar t be 1 and there is no scalar t. Okay, so we proved this. Cauchy-Schwarz was right, and this video is complete. Subscribe to my channel if you love videos like this. Tell your family and friends. Leave a comment. As always, watch and learn.